I'm going to introduce the gentleman standing next to me while he's standing next to me, so you'll know what he looks like. So this is Blacki Migliozzi, who's coming to us from the New York Times, where he's a graphics editor, and you've probably seen a good deal of his work. He, before that, worked for Bloomberg, where you also perhaps saw much of his work because it focuses primarily at the intersection of climate science, economic policy, and politics, topics that I bet are dear to many of us here in this room. But to give him a proper introduction, I should tell you, I told you he comes from the New York Times, but he, before that, was much farther south. He did his bachelor's degree in discrete mathematics, and he has also a certificate in nanomaterials. I should have asked you what that means. And so he did that as his bachelor's at Georgia Tech, and then he continued on to a master's at Georgia Tech in human-computer interaction, which you see as a theme among many of our speakers here. And just to tell you one thing that I didn't know about him, I knew about his work in data graphics, but I did not know that he co-founded something called Brooklyn Bio, which is a for-hire synthetic biology research group. Maybe somehow this will come up in the discussion. I'll turn it over to you, Blacki. Thank you.
I guess all that means is that I, was really into science and kind of took a lot of different paths. But yes, first, my name is Blacki. It's my real name. My mom was sort of like a hippie or something in the 80s in Costa Rica. And she named me after a little dog she had when she was a little girl. She never planned to name her son after the dog. But it just happened, and she looked in my eyes and just blurted my name out loud, like right then and there. So it's a lot of love in that, and I own it. And yeah, I'm a 3-time iGEM alumni, and through that started a for-hire research group, but doing synthetic biology. So I own a lab, but with my friends, which is really great. But I also work at the New York Times, and I'm very lucky because I get to work on the graphics team at the New York Times, which is full of a bunch of my data viz heroes, as well as genuinely talented and very humble, amazing journalists. So yeah, I'm going to tell you about how I kind of fell into doing visual storytelling and climate data. This was, when I worked at Bloomberg, this was the very first climate graphic I worked on. And what this is over time, every time, over the 100 years of data, every time there was a heat record, a global average heat record, we kind of left this painted, record. And so you can see all the records keep kind of going up. So it's getting hotter. That's all it is. And really, that was just the point of the graphic. It was actually, in 2015, it was 2014 that it was the hottest year on record. And unfortunately, this graphic kind of had way more life than we ever expected, because 2014 was the hottest year on record, 2015 was the hottest year on record, 2016 was the hottest year on record. And we also broke a ton of heat years, records during the months. Yeah, and being my first climate graphic and all of a sudden getting a presidential tweet, I was just oh my gosh, my mom was very proud. But that maybe meant something different then. It's very different to get a presidential tweet these days. Yeah, so the whole point of that was that the Earth is warming. And what we wanted to show after was that it was actually due to humans. And so we made this graphic, my colleague Eric Roston and I. What you're seeing is the observed temperature, and broken out, we broke out climate forcings that humans have no impact on, for example, orbital changes or solar effects or volcanoes. And you can see none of those things tracked the observed temperature. And if you even try to combine these things together, they don't track the observed temperature. So these natural forcings, they don't correlate with the observed temperature. Next we showed this anthropogenic, the things that humans actually do have an impact on. So whether it's land use or like ozone pollution or aerosols. Aerosols actually make it cooler. The one thing you do find is that greenhouse gases is the thing that tracks this observed temperature. And if you combine the anthropogenic human factors, you see that it tracks pretty well, because it's data viz, we show you all the things together and let you explore. We sort of took a children's book approach here. We were like, is it the ozone, or is it aerosols? Is it, it is greenhouse gases. It was actually very inspired by Where is Spot, the book. But because we took that children's book approach, we try to be kind of thorough with methodology. And now that said, it's not like in news we don't really write white papers usually or anything, but usually the words are dedicated to the story and not to the method. So, and we were very lucky. We got to work with like NASA GIS on this, Gavin Schmidt and Kate Marvel, amazing climate scientists and communicators. And it also, I'm kind of just throwing this in here, but it also made it into the congressional record as something that basically shows that humans do have an impact on climate change. So the Earth is warming, it's due to human impact, and it's primarily due to these things called greenhouse gases. So we wanted to show kind of a deep dive after this, and Eric and I also worked on this. We took a deep dive in one of those greenhouse gases, that's CO2. And this is an out-of-date picture. It was around the time of Paris, and this number is out of date, but what we envisioned was sort of like a big billboard that maybe we can convince Bloomberg to put in like Paris somewhere that was just like this updating, ticking number, sort of like the debt clock. But like this website, probably, I don't know how many people ever actually scrolled down, right? It was just like this number. Ideally, we give you some intuition about what parts per million means. We give you some context about, like what you're actually seeing, like how CO2 is actually measured, where we are on this hockey stick, the seasonality of it, and a bunch of stuff. I'm gonna kind of just skip by. Our methodology got a little bigger this time. We were luckily at Bloomberg, there's a bunch of amazing researchers there, and there was some quants that had a background in like geoscience or something, and they were just really excited to get to work on this. So why would we have to write such a big paper? Well, just to get this like funny little ticking number, we had to forecast out, like monthly data out a year. But we felt confident with doing this because it's like it's a very regular pattern you see there. It's not a controversial thing to forecast as a news organization. And really, it's funny because we did this thing purely out of an aesthetic kind of storytelling thing, and it was like something a scientist probably would never do. I'm sure a bunch of scientists in this room are cringing at the fact that I, put a bunch of insignificant digits there. But, there's a cool figure from the paper. So we zoomed in on a particular greenhouse gas. We also wanted to zoom in on a place that would be most affected by climate change. Arguably, the Arctic is one of these places. I'm going to kind of breeze through this part, but Eric and I wrote like this 3-part, feature story on this. I'm just going to show you a couple graphs. We kind of touched on how the Arctic feels the effects more, in a sense, through Arctic amplification. You can see the temperatures in the Arctic versus the observed temperatures. Here, this is kind of a weird metric, cumulative daily tally of degrees below freezing. We get less days that have degrees below freezing. This is sea ice extent. So this is like the area, or we tried to show, where the permafrost has been melting over the last 30 years, or the age of the ice. We're doing this all in a way that you're seeing the old ice is like the dark blue, the light ice is the light blue, and light ice melts faster. But we're doing this in a way where we're trying to target this at a general audience and present really kind of complex data in a way that might get somebody, excited to look at something. And I felt really honored about this. Honestly, this is like one of I can't believe this happened. Climate Feedback is a website that goes and does essentially like peer review on media articles And it has scientists doing this. Hopefully, if any of you have ever contributed to this or have not, you maybe should. But we got the highest scientific credibility score on there. And this was like at a time when there was not that many, but we're still on there, and I was very proud of it. Now this is some work I did with Nadia Popovich. This is at the New York Times showing how winters have been getting warmer. You can see the last 30 years there highlighted where it barely crosses below this blue line. What does this data look like geographically? Well, we got data going back 100 years. In the US, it's kind of coarse grain. But this is like not the way a scientist would want this data. Here's a place where the science actually informs the aesthetics. You see small multiples presented all the time. I would argue this is not necessarily the best way to represent this data. And if you ask a scientist, they want to roll this up in like kind of longer time periods. If you do that, you can start to see a trend. If you do it too much, or actually the right amount, relatively speaking, like 30-year averages is usually what climate scientists like. You actually see a trend here, but it's like you've kind of rolled all that data up into 4 data points. But yeah, winters in the U.S. Have, on average, been getting warmer, and Great Plains are probably feeling that. The northern Great Plains are feeling that the worst. We also have to make stuff in print. This is like a lot of work. This is the next piece is a piece of climate database reporting. This was right after Hurricane Harvey. A bunch of my colleagues, this is before I worked there at the New York Times, did breaking news coverage of how flooding in Houston actually caused a bunch of hazardous pollutants to spill over into Houston. And, Haruko Tabuchi, kind of the lead climate reporter on this story, had always wanted to do kind of a national view of this. When I first came to the Times, this was almost like the first thing I was asked to do. And, we set out to join all these data sets together that, cataloged like different facilities and the chemicals used at these facilities, and join them with like flood zone data. And it's a ridiculous 65 gigabyte JSON file that I had here. But just to give you a sense of the scale, there's about, just one of these databases had 21,000 facilities that, the data was actually in just like the types of chemicals, not even like broken out so much by facilities. But and then the flood zone data has issues. We kind of have to acknowledge that in the story. This is actually from a Bloomberg story that I didn't do, but it's just describing some of the issues. I recommend you checking out some of the issues with flood data. You can see, especially across state lines, it's radically different. Why would it be that way? So we looked at 100-year flood zones, and we did like a spatial join, like a database join with these toxic sites, these facilities that handle toxic chemicals and pollutants. The next thing is I'm showing you here this is kind of behind the scenes. It's like, there's an element of having to fact check this stuff, right? And, I, at first glance, see these red dots, and I don't see, I don't see flood zones underneath them, and I get, really nervous. Turns out, flood zones actually is very high-resolution data, and, it was just happened to be the UI that I was looking at it just kind of made it look like there was just dots. So I had to actually go back and zoom in on every, broke the US into parts and zoomed in on anywhere it looked like it may be off at all. So it's I'm kind of just pointing at the fact that fact-checking, doing data viz in the news and working with data in the news, just the more involved it gets, the harder it becomes to fact-check your work. At the end, we found 2,500 sites that handle toxic chemicals located in flood-prone areas, and this was important because Obama had right before one of the last things he did, he put an executive order requiring it that anybody building stuff would have to factor in climate change into their buildings, or at least think through that. And it was also one of the first things that got revoked in like the Trump administration. So again, in print, let me just show you. More recently, just this 2 weeks ago, this was Midwest flooding. This just shows the sort of rivers overflowing. And this is actually, this was breaking news, had to do this in a day. And we'd worked with this data before. We had kind of like a lot of the thinking put into this because we kind of do this stuff all the time. And it was still very difficult to actually make something automatable that we can easily turn out a graphic like this. This graphic is something that Brad Plumer and I worked on. This is basically, so right now what you're looking at is a model that shows into the future, 2050, if we didn't do anything about, if we didn't apply any new emission policies, we would basically be business as usual. And yet we have these stated goals, like the Paris Pledge, or Obama had stated a goal for 2050. Now, the idea in the graphic was like, what happens if you applied, let's say, a policy that is already out in the world, like one in a specific place, like British Columbia, or like New York City's clean electricity goal, and you took that and applied it to the whole rest of the US? Like, how much emissions could you actually cut? And you can see already with just 2 of these things applied, we could already meet Paris, applied to the whole US, of course, but we could already meet Paris, but there's still like a lot of other sort of, we kind of picked out 7 policies that we felt were like kind of reasonable and were like within the grasp of the model that we were working with. And you can see like some of these just don't get you far enough. So it's kind of, there's 2 kind of things going on here. Like we can apply certain policies and get far fast, and then we still aren't all the way there, So we use this energy policy simulator that the Energy Innovation Institute put out. Basically, it's a tool online to kind of help policymakers make decisions, more data-driven decisions. And we actually, like Brad primarily, worked with Energy Innovation Institute to really refine those kind of the numbers associated with the model to make those be as realistic to those policies as possible, so that when we did apply those to the rest of the U.S., we get so far. And I'm just showing you how I just keep showing you the print stuff because it's a consideration up front the whole time. I'm thinking both in terms of interactivity and how can you read this statically, and you usually have to do 2 separate graphics, which is kind of crazy. So last, I'm going to mention this. This is a piece that Nadia Popovich and I worked on. Basically, I for me at least, I go home in the holidays and I sit down and I try to explain to my grandma what I'm working on. And, I like what I do. I kind of sit her in front of Netflix and I'm showing her all these climate change documentaries. And it turns out it's hard to kind of get her to really feel something about it. She's very conservative politically and stuff. But in general, it's not your politics. It's that climate change is abstract. It is. I think that's apolitical. It's like a long-term thing. You have to think on different timescales. And there's data to back this up, right? This is from a piece Nadia worked on, but it's from this Yale Climate Communication Survey. And on the left, you see people in the United States were asked, will global warming harm somebody else in the United States? And a lot of people were like, yes, of course. But on the right, you can see, will global warming harm me in particular? And nobody thinks that for some reason. So we were really trying to figure out a way to make something that could bring you really connected to this data. And there's sort of a data viz trope, which is find yourself within the data. It's kind of fun. Very often, this is a piece Amanda Cox did about tax day. Very often you find yourself within these sorts of graphics that are this is where I am in my tax bracket. And, I've also worked on another tax thing where you find yourself within it. But we wanted to find yourself within climate data. So what does that mean? So we built this tool. Really, it's just part of the story. I don't like to think of it as a tool. you can put in your hometown. This is where I'm from, Lake Worth, Florida. You put in when you were born. And you see when you were born, there was 108 days that reached above 90-degree days, 108 hot days. And today, you actually have about like 4 months on average that are above 90-degree days in Lake Worth, Florida. So these climate models tell you that you're actually going to get something up to about 6 months worth of hot days in Florida when I'm 80. And so our readership at the time is primarily the US, but we also really, America's kind of okay when you look at it on the whole world scale. And we really wanted to like put you in a perspective where, somebody else that's gonna be really impacted by this warming. So a place like Jakarta normally would go from like 5 months to all year round, 90-degree days. It's kind of insane. And why does this matter? Well, people die because of heat strokes. It's a real thing. It requires air conditioning. You can kind of adapt by going inside if you have AC, but in a lot of places around the world, people don't. So anyways, please, I recommend you go in and checking it out. It's not just this interactive tool, like we said, it's also a story we wrote, like an article. So, and also, go check it out, New York Times, Hometown Heat. We really couldn't have done this. We thought this would be a lot easier. We attempted to personalize climate data, but when we actually went to do this, these climate data is kind of rolled up in such a way where it's telling you something about the whole Earth at once, and it's on Earth scale, sort of and it's when you try to zoom in on it, at least the way the data has been rolled up, it's not really okay to do. So it turned out to be very hard, and the research group we worked with, Climate Impact Lab, they really helped us a ton. We had a lot of it's one of these things where we came to them with a storytelling kind of idea, and we were like, yeah, why can't you just average or do rolling averages on every lat long on Earth for the 30-year periods for a single data point? And they're like, yeah, you can. Maybe, but why would a scientist ever do that? It's a lot of computational effort. We had to, the storytelling guided the sort of data there. And they wrote a white paper out of it. I can talk a lot more about this, but I'm just gonna go through, leave you. Fact-checking this is also a hella chore. It was, I wrote some machine learning to cluster, we were grouping together historical data and forecast data, and this stuff is spatially average, so I did some machine learning just to cluster sort of line charts together. And we also had to make decisions about where, and this was basically a back and forth between Climate Impact Lab and us, but we had to make decisions where we would, we felt the uncertainty was too high, where we would exclude stuff. That happened to be a lot of places where it has really nice weather, around the coasts and stuff. So San Francisco, you go there and it's oh, yeah, no, sorry, this doesn't work for you. But, and print. So yeah, this is what it turned out. Internationally was a whole different graphic. I just last thing I want to say is just, climate modeling is one of the most computationally intensive things humans have ever done. And we've done this to try to understand the world. And I honestly feel that it's kind of up to journalists and up to everyone who we all should be looking at this and trying to explain this stuff to everyone. So that's it. Thank you.
That was just perfect, and I think you know what I mean now about explore and explain, and we're going to talk about that with everyone. But while the other speakers come up, we can take one question for just Blacki, and I'll just invite the other speakers to come up and join me here. So come to the microphone, please, with your question.
Yeah, actually, I wanted to ask you, what happens when you have data that is messy, like the messy data that was presented by the previous speaker? And what do you think about her results in terms of what would the New York Times do if you're dealing with data sets that have missing information, knowing that by preserving the structure, you're going to increase confidence in your data. Those seem to be choices that the media are going to have to make more and more. I'm just wondering how you would apply that learning to the data that you deal with in your visualization.
Yeah, I think, earlier research was kind of more about perception, and that's a huge part of all this. We are sort of balancing a whole different set of trade-offs. The trade-offs that we're balancing in the news is just, like maybe somebody's never even looked at a chart like this. You're having to explain a lot. You also want to get people to want to look at the chart, which is kind of, you put a lot of effort just to make something beautiful and engaging. But then you're also trying to kind of keep it grounded with the data, like that, and this is usually coming from like a scientist. So like, I don't really have, I'm always conflicted about everything I do. So, it's one of these things where like there's a lot of decisions, and the goal is just to feel, like you made the best decision you could at any moment. So, yeah. I don't know if that answers anything.